Okay, my dear friends, hoping that you are all fine with blessings of Almighty Allah. And here we are starting now our paper two. We will try to solve it. First of all, I have chosen it as October, November. This is year, October, November 2020 series and paper two, variant one. Time allowed 1 hour, 15 minutes. And we will also try to wind up this paper in this much allowed time, and everything is there. So this paper is for 60 marks, and let's start it without any delay now. So starting from the beginning, this is as usual formula sheet, and sorry, those were the constant numerical values for different constants in the syllabus, and then the formula sheet is there. And we are starting with the first question, question number one, without any delay. So we will try our best that we can get the answer this paper on time. We can try to solve this paper in a little bit fast track today because all the topics we have already discussed and mostly the answers I have we will be writing now. Calculate, define the moment of a force about a point. So that's very simple. Moment of a force, that is equal to force times, I will write this way, perpendicular distance from point or pivot to the force or to the line of action of force. I'm writing just to the force. This lesson is already being recorded, so it will be shared with you people. Now, determine the SI base units of the moment of a force. SI base units of what? Of the moment of a force. That's what we have to do now. So, my dear friends, let's start with the moment of force definition. Just we did know the definition, and the same definition we will be just using to get this answer as soon as possible. We can do it quickly. So here, my dear friends, first of all, the definition of moment. Just let's start with that, and we need SI base units. So moment, my dear friends, it is equal to force times distance. Then force is equal to ma times then distance here. And then, my dear friends, mass is in kilogram and acceleration is meters per second square times distance is meter. So as we will simplify, it will be equal to kilogram meter square per second square. So very simple. Wherever you find any difficulty, you can ask me. They want SI base units for moment of a force. And moment of force, just we have defined up that it is the force times perpendicular distance from the pivot or point to the force, or you can say line of action of force. So same equation we have written, but we are not going to use the force unit Newton. They said SI base unit, so I just write it. I have written F is equal to MA and then times D distance as it is, so I'm writing the units and simplifying that. Now come forward. Let's see this question. A uniform rigid rod of length 2.4 meters. So the length of this rod is given as shown in figure. So then the rod has a weight of 5.2 Newton. Weight is given, the length of the rod is given, and the is made of wood of density this. So density is also given. Calculate the cross-sectional area in millimeter square of the rod. See, all other units are in meters. So it means we need to use system international units, and we will start it now. First of all, we will find the, from weight we need mass because density is mass per unit volume. Then we can calculate from density the magnitude of volume, and then we can calculate the area. Let's start. Volume of this one, volume will be equal to area times length. So if we can calculate volume, length is already there. So area simply can be calculated by V over L. Let's proceed step by step. First of all, my dear friends, weight W is equal to mg. Then uh, weight W is equal to mg. Then, my dear friends, mass will be equal to weight over g. So 5.2 over 5.2 over 9.8. To save time, I have already calculated. When we simplify it, we are getting almost 0.53 kilogram mass we have calculated. Now density will help us out. Density is already there. Mass we have calculated. We can calculate the volume now. As density is equal to mass per unit volume, so we need volume. So volume will be equal to mass over density. It is better, dear sons, that we should use capital V in place of small v for volume. So capital V. So then mass 0.53 and density is given already, and that is how much? That is 700. That is 790. As I'm simplifying it, I'm getting the volume equal to, as I told you, calculations I have done already. 6.71. You can also confirm, cross check. 6.71 times 10 raised to power minus 4, and this is in meter cubes. And we need area in meter square. But wait a minute. First of all, volume we have calculated as I wrote up. Now, this is A into L equal to 6.71 times 10 raised to the power minus 4 meter cube, yes, sons. We need area in millimeter square. We will calculate, but area will be equal to now 6.71 times 10 raised to power minus 4 over L, and length is given already. How much? 2.4. And that is all in meters. When I'm simplifying this, what I'm getting? When I'm simplifying this, my dear friends, I'm getting area is equal to, I will go down now here so that I can have more space. So here, my dear friends, area for me comes to be 2.796 times 10 raised to the power of minus 4. But that is in meter square. I need this area in millimeter square. In what? In millimeter square. So what should I do? When we are converting meter to millimeter, we need to multiply by 10 raised to power 3. So when we need to convert from meter square to millimeter square, my dear friends, we need to multiply by 10 raised to power 6. Okay, so 10 raised to power 6, that's what I'm going to do. So 2.796 times 10 raised to power minus 4 times 10 raised to power 6. Now it is in millimeter square. And as I'm simplifying, so it will be multiplied by 100 actually. So 279.6 millimeter square. I can round it off and I can write the answer, dear friends, simply 280 millimeter cube. Here, if anybody having any problem can ask me. Question started with moment of a force. We have written the definition of moment of a force. Then, my dear friends, they ask for the SI base unit for the moment of a force. Then a rod was given, its length was given, weight of the rod is given, and the density of the rod, density of the wood with which the rod is made, that is given. We need to calculate the area of cross section, but in millimeter square. No problem, conversion will be later on. We know for this sort of rod, volume is equal to pi r square h, or A times L. So area will be equal to volume over length. So it means we need to get the volume. Density is there. Volume we can get if we can calculate the mass. So weight was there. I calculated first the mass by W is equal to mg. Then density is equal to mass over volume. I calculated the volume, that came to be in meter cube. 6.71 times 10 raised to power minus 4 meter cube. And then, my dear friends, volume is as I wrote the formula, then making area as the subject of equation and converting from meter square to millimeter square. Here's the criteria which I have written. So we got 279.6 millimeter square. So it means we can write 280 millimeter square. If any one of you is having any problem, please feel free, you can ask me. Now, a fishing rod AB made from the rod in B as shown in figure. How it is made from? It means same wood, same density. The length of that was 2.4. So 1.2 plus 0.6, 1.8 plus 0.6. So total length here is also 2.4 meters. So same rod. It is not to the scale, but now end A of the rod rests on the ground and a string is attached to the other end B. Here you can see the string. A support stick exerts a force perpendicular to the rod at point C here. This is a stick support which is providing a force. So the weight of the rod acts at point D, and that will be at the center because it was a uniform rod. So weight will act at the center of the gravity. For regular shaped object, for uniform shaped object, it will be always at the center. So 2.4 divided by 2, it is 1.2. So from end A, weight is acting at 1.2 meters. From end B also weight is acting at 1.2 meters. The tension T in the string is in a perpendicular direction, perpendicular to the rod. This tension T. So C angle is there 90-degree perpendicular. The rod is in equilibrium and is inclined at an angle of 56 degree to the horizontal here. You can see this angle is given. The forces and the distances along the rod points A, B, C, and D are shown in figure 1.2. State the component of the weight that is perpendicular to the rod. That's not a problem. See, component of the weight that will be perpendicular to the rod, that will be this way. And the other one will be along the rod this way. So they want this component, simply it will be equal to W sine of theta. This implies that it will be equal to W how much? 5.2 times sine how much? 56 degree. To save our time, my dear friends, answer comes to be, just give me a moment. Answer comes to be 4.311. The answer is, when we calculate it, answer comes to be 4.311. So simply two significant figures are always preferred. So 4.3 Newton is the answer. That is a straightforward question, not a big issue. Perpendicular component to the weight of the weight we have calculated to the rod. Now next one, see, by taking the moments about and A of the rod, calculate the tension T. Moment about and A. So A is the pivot and it is in equilibrium. So my dear friends, total clockwise moment is equal to total anti-clockwise moment. Now, always we have to take the perpendicular. So we are not going to use now 5.2. We are going to use this 4.3, which we have calculated. So this one now is 4.3. This is the pivot. So my dear friends, this string will cause anti-clockwise movement because it will try to move it this way. This weight component will also be causing anti-clockwise movement, and this stick will cause what? It will be causing clockwise movement. So for a body to be in equilibrium, total clockwise movement is equal to total anti-clockwise movement. So that's what we will be doing now. And my dear friend, so clockwise movements is equal to anti-clockwise movement. So, my dear friend, I can write total clockwise movement is equal to, or better to say total anti-clockwise movement. Are you with me? Total anti-clockwise movement is equal to total clockwise movement as it is in equilibrium. So these movements should be equal. Now, my dear friends, see, anti-clockwise movement, T, which we have to find, times 2.4, because pivot, this point A is at a distance, this perpendicular distance, my dear friend, from here till here. So that is 2.4. So first of all, I'm writing T times 2.4 plus the weight, that is 4.3. And how much is the distance? This is 1.2. From here till here, this distance is 1.2. So my dear friends, plus 4.3 times 1.2 equal to, next is this stick one. So that is 4.6 times 1.8. 4.6 times 1.8. Why 1.8? Because the distance from this point to this point, it is 1.2 plus 0.6, that will become 1.8. And when I will simplify this all, because 3 marks are there, so you have to do it. And when I will simplify this all, my dear friends, answer will be equal to 1.3 Newton. So you can check it out. I don't want to waste time in these calculations. I have already finished them up. So answer is 1.3 Newton, my dear friends. Again, first of all, this part, this is the same rod as shown. All the distances are given and all the forces are given. So the stick force 4.6 Newton is perpendicular to the distance from the pivot. Tension is also, which we have to find out, that is also perpendicular from the pivot. The distance is perpendicular from the pivot to the force tension, but the weight was not at perpendicular. So we have calculated first the component, but component of the weight which is perpendicular to the rod. So it is W sine theta. We calculated it and we got the answer 4.3. Now, ultimately, all the forces, weight, the force exerted by the stick, and the tension of the string, all the forces are at a perpendicular distance from the pivot. So that is something needed, and always we are using perpendicular distances. Then, my dear friends, the next is we were supposed to calculate the moment, tension T. Now see, tension is causing anti-clockwise movement. Similarly, weight is causing anti-clockwise movement if we take point A of the rod as the pivot. Then the force from the stick, which is upward, it is causing clockwise movement. And as the rod is in equilibrium, so total clockwise movement should be equal to total anti-clockwise movement. And then using the equation of movement, that is force times distance, we have inserted the forces times moment, adding them together and simplifying them together, we got the answer. Tension is equal to how much? 1.3 Newton. And this is first time. The first question is very rarely it is coming for this much comprehensive marks. So this is for 9 marks. Now, my dear friends, Mahad, Ahmad Rahma, Muhammad Ashraf, Muhammad Naji, my dear friend, anybody having any problem here, please feel free, you
Mm,
can ask me.
I understand, teacher.
Yes, understood.
Okay, let's move to the next question then, my dear friends. So next question is, yeah, maybe we have done it already, but of course it has come in the paper. So we will be, a small block is lifted vertically upwards by a toy aircraft. You can see here, and block is there as shown in figure 2.1. As the block is moving upwards, the string breaks at time t is equal to 0. So the block initially continues moving upward. It means for a very short time it was going upward still. Initially, let's suppose it is moving upward and then falls and hit the ground at time t is equal to 0. So then it falls down here. Okay. So, and time t is equal to 0, it hits the ground. Fine. The variation with time t of the velocity v of the block is shown in figure 2.2. Now see, this is velocity time graph. Now few things should be very clear to us, that if we need to calculate the displacement, we will take the area under the graph. And if we need to calculate, dear sons, this acceleration, that will be equal to gradient of the graph, and this gradient will be constant. And this gradient will be what? It will be constant as the graph is a straight line. So very basic and the very nice. I don't think there is any complication in this graph. So air resistance is negligible. So of course it will be falling. It means A is equal to G with acceleration due to gravity. State the feature of the graph in figure 2.2 that shows the block has a constant acceleration. So my dear friends, you can say simply, they said, if they have said only acceleration, you can say gradient of the graph give the acceleration. But they said constant acceleration the block has. So it means constant gradient of the graph. Gradient of the graph is constant. Even you can write that way. I think that will be more better, but now I have written it like this. So why the acceleration is constant? So our answer will be the gradient of the graph is what? Gradient of the graph is constant. Okay, so more suitable to write this way. So I wrote just constant gradient to save over time. Now use the figure to determine the height of the block above the ground when the string breaks at time t is equal to 0. It means we want to calculate, this was time t is equal to 0. We want to calculate this one height, by the way. So very simple. We can calculate this one displacement and we can calculate this one displacement. As this is height, they did not ask us to calculate displacement. So height is a scalar quantity. So what I will do, this is a triangle. The distance here, that will be, wait a minute. And we did it in the beginning. We were making mistake, but then mashallah, all of you went to become a professor. You became, and you people, okay, sorry. So this one will be positive. This one will be negative. But as it is height, so one will be positive, other one will be negative. So I wrote it negative, no. But I'm not going to use it as negative. Whatever the area here, this area, I will do minus this area. Okay, because it is height, not displacement. So if it was displacement, answer going to be negative, but we are not going to do it displacement right now. We need to calculate height. That is a scalar quantity. So my dear friends, I'm simply writing height will be equal to both our triangles. 1 over 2 times base into height. So what is the base here? That is, okay, I will write it so that you can understand later. 0.90 minus 0.2. That is the base times height. This one. So that is how much? That is simply 6.86. So I'm not even using this negative value because already, so 6.86. Then minus 1 over 2 times 0.2 times 1.96 times 1.96. So simply here base is 0.2 and height is 1.96. And as we will simplify, so today I'm not telling you people to use the calculators. So we are getting here 2.401 minus 0.196, 0.196. And my dear sons, when I'm simplifying it, I'm getting 2.2 meters. That is simply the height. So ignore the negative signs. But one thing you have to calculate, because we have to check this one, take this one only. So this minus this. And no need to use this one negative and this one positive because it is height, that is a scalar quantity. Just from the more you can subtract the smaller one, as in general we are doing. So you will get the answer. The more magnitude, you can subtract the smaller magnitude. That's what I mean. And you will get the height equal to how much? 2.2 meters. Please, my dear friends, if any one of you having any question here, feel free and you people can ask me. Okay, let's move forward then. What is next? So next is the block has a weight. How much? The block has a weight of 0.86 Newton. Weight is given. Calculate W. W is given. Calculate the difference in the gravitational potential energy of the block between T is equal to 0. And so simply, so delta EP, we can say mg delta H. Mg is already given. Here be very careful. Don't multiply 0.86 with 9.8. It is already mg. So I can write here like this. So 0.86 times, dear sons, 2.2 times what? 2.2. Please, if there is anything, you can ask me. And as we simplify it, we are getting 1.9. So here I'm writing 1.9 joules, but please, don't multiply it with G. Already it is weight, so multiply it with G already. Now, yeah, this question now. On figure 2.3, sketch a line to show the variation of the distance moved by the block with time t from t is equal to 0 to t is equal to 0.20 seconds. Numerical values of the distance are not required. Okay. Now see, you need to wake up. It is distance time graph. And this one, my dear friends, this one is velocity time graph. He wants it from 0 to 2. C at 0, velocity is this. And at 0.20, the velocity is equal to what? 0. So what is happening? It means velocity is decreasing. If velocity is decreasing, what sort of graph is this distance time graph? My dear friends, something like this. And in the end, you should try that this is bit horizontal. You know why it should be with horizontal? That means gradient will be equal to 0. This implies that velocity is 0. So at point 20, velocity should be 0. So it should not be ala tool with decreasing gradient. At the end, it should be horizontal lazim. Please, my send C assigns 2 marks. So you need to think it very carefully. So 0 to t point 20. So the same graph, that is velocity time graph, we need to write it, or we need to draw it in terms of distance time graph. And by the way, see this uh, in the beginning, gradient is constant and gradient is more, so velocity will be more, and then gradient keep on decreasing, which shows that velocity is decreasing, and ultimately at point 20, velocity becomes 0. And here also in the end, at point 20, the graph should be almost horizontal. Mahad, please comment on this. Is that okay? Mahad may be sleeping. Mahad, are you there?
Yes,
So is that okay or no?
yes, it's okay.
Okay, fine. Muhammad Naji, is that fine?
Yes, sir.
Okay, then next is now a block of greater mass is now released from the same height with the same upward velocity. Air resistance is still negligible. State and explain the effect, if any, of the increased mass on the speed with which the block hits the ground. Same speed. My goodness. Why same speed? Because speed is not affected by mass. How? You can write it this way. Another way also you can use. But why did I write this? You know, this is because you don't need to write this what I'm writing this one now, because V is equal to 2gh root. So speed for a falling body, it is not, it is depending on the height of the body from which it is dropped. It has no concern with the mass of the body. Why? From where I brought this equation, by the way? See, my dear friends, you don't need to write this in the exam, but you must be knowing it. How? See, if the air resistance is ignored, so 1 over 2 mv square, the kinetic energy just before hitting the ground or on hitting the ground will be equal to the GPE at the top. In other words, the loss in GPE is equal to gain in KE. The loss in GPE is equal to gain in KE. So here we can write then mgh. So mass is cancelled. So what is left behind here, sons? V square. And I'm not writing V square, so I will put 2gh root. So basically, speed depends on the height. And what is mentioned? It is mentioned very clearly that it is dropped from the same height. So if it is dropped from the same height, so speed will not be affected, even whatever the mass. Okay. Another way, if you want to do it not in terms of energy, you want to say it in some other terms, then dear friends, we can also call it, like we can say that the air resistance is negligible. So it will be having the same acceleration due to gravity as it was having before the mass was less. So anyway, you can, right? So same acceleration due to gravity, it means same speed when it is hitting the ground. So, or you can also write the answer for this, or no, air resistance in shortcut I can say. So A is equal to G So same speed on hitting the ground, same speed on hitting ground with different mass. Different, they said mass is doubled. Even you can use this one also, not a problem. This answer or this answer. Please, my dear sons, if there is any question, any problem, dear students, feel free. You can ask me.
Understood.
Yes, yes, my dear. Is that okay with everybody?
Yeah.
Yes.
Okay. Then let's move to the, this question is also 9 marks. Oh, define force. So, you know, F is equal to ma, but define force now, we are preferring to write, my dear sons, rate of change of momentum. We are preferring this answer, rate of change of momentum. Okay, that is done. Now, a ball falls vertically downward towards a horizontal floor and then rebounds along its original path as shown in figure 3.1. So here, and then it just rebounds along its original path. The ball reaches the floor with a speed of this, we can call it u, and the ball is then in contact with the floor for a time of this, very important this time, before leaving it with speed of 1.7 meters per second. So the mass of the ball is this. So this we can say we calculate the loss of kinetic energy during the collision. What to do here? Loss of kinetic energy, we can calculate the difference in kinetic energy. So my dear friends, loss of kinetic energy is equal to 1 over 2 mv square minus 1 over 2 mu square. As it is kinetic energy, loss of kinetic energy, scalar quantity, my dear friends, it is loss. So what I'm going to do, I'm writing the values here in a switched way. Like I can write 1 over 2 mass. Okay, wait, 0.062 times v square. So I can write here 1.7 square minus 3.8 square. So as I'm simplifying, my dear friends, I'm getting the answer equal to minus 0.36. Okay, so no need to write minus. Loss of kinetic energy, simply you can write here 0.36 joules. Please, this was so simple, quite simple question. And even if you are doing it like in this way, you are writing 1 over 2 mu square minus 1 over 2 mv square. Even that will work. No problem. Why so? Because it is loss. So greater minus lower value. So you can write 1 over 2 times 0.062 times 3.8 square, then in bracket minus 1.7 square. Still the answer will be same, but then negative sign will not come. Okay, even the negative sign is coming because kinetic energy is a scalar quantity. So negative sign is not having any significance with that. So that will be 0.36 directly joules. But if you are doing it like 1 over 2 mu square minus 1 over 2 mv square, because loss more in the initial kinetic energy will be more, final kinetic energy will be less. So that way even you can do it. That's not a problem. So anyway, it's okay for you. Now next. This is a straightforward. So determine the magnitude of the change in momentum of the ball during the collision. Now this is bit. You have to wake up. Change in momentum. My dear friends, change in momentum is mv minus mu. mv minus mu. Change in momentum, that is equal to final minus initial. Now momentum is a vector quantity, no directions will matter. Dear sons, my dear friends, m is equal to v minus u. Now, what is m? 0.062. Then v. V, see, it is moving upward. So velocity moving up, body moving upward or moving towards right. Convention is we are taking it positive. Body moving towards left or falling downward. It is taken as negative. So my dear friends, final velocity is 1.7 minus into minus 3.8. One minus is because of the formula and other minus because of the direction. Because momentum, we cannot ignore direction. Momentum is a vector quantity. So as we simplify, dear friends, we are getting the answer 0.34 Newton second. You can check it out. So 0.34 Newton second is the change in momentum. Is that okay? So in this way, we can calculate this momentum, but here you cannot ignore the sign conversion because momentum is a vector quantity. So body momentum is having the same direction as the direction of the velocity. So convention is velocity towards right, or body is thrown upward, that velocity is positive, and velocity towards body moving towards left or falling downward, that velocity is taken as what? Negative. So as 3.8, this is falling downward, so it will be taken as a negative, and this one will be taken as what? Positive. Place the values and we can get the answer. Now, show that the magnitude of the average resultant force acting on the ball during the collision is 4.2. During the collision is how much? 4.2. Now, for this, what to do? That is quite simple. That is quite simple because according to Newton's second law of motion, as in the beginning we wrote the definition, it is force is the rate of change of momentum. So what is the change in momentum? That is 0.34. Time is there. It was given in the beginning. See, 0.081. So that's why always underline the numerical value 0.081. And when you will simplify, of course, answer will be equal to 4.2 newtons. So in this way, we can calculate the resultant force on the body. Now, my dear friends, we will be moving forward to the next question. But those two questions you need to think, and let's see how we are solving them. So, my dear friends, here now, this was simply according to the definition of momentum. Now, use the information in 3 to calculate the magnitude of the average force on the floor on the ball during the collision. Force on the ball during the collision. So, my dear friends, here, so when during the collision, two forces are acting on the ball. Let me draw the ball here. Let's suppose this is the floor and this is the ball. Floor and this is the ball. So, my dear friends, there are two forces. One is the weight of the ball, that is downward. That is what? Downward. And there is also a normal reaction that is acting on the ball, and it is in the upward direction. That is the normal force. Now, what we are supposed to do, we are supposed to calculate the average force. So average force, these forces are in opposite direction. So that will be the difference of these two forces. Whereas, if you ask me the net force here, dear friends, the net force, F net, that is equal to 4.2. Already we have calculated here the net force, the average force, okay? So now, what can we do here, dear friends? Net force, that will be equal to N minus W. And that during the collision force that we need to calculate N. So F net we have calculated already 4.2. N is unknown and weight is mg. So that is 0.062 times 9.81. And dear friends, on simplification, when we are making N as the subject of equation, we are getting the answer 4.8. So average force is 4.8 Newton. Please look at this diagram and then resultant force and this all scenario and check it out. If there is any question, ask me. The average force on the ball. See, this was the average force of the floor on the ball during the collision. Now the average force of the ball on the floor during the collision. Now think something on this. I'm giving you few seconds to think and then you see this part also and then let me know what can be this answer. This is leading towards something which we have discussed. And what is that? Two forces. And check the statement of one, check the statement of two. This will lead to one of the laws. Please, everybody comment and write in the chat box what can be this average force now. So only one comment. Why? What about the others? Others are not in energy today. I think they are just crying, sleeping. Okay, Ahmad, your answer is correct, but why? So I'm writing this answer. Also 4.8 Newton. You should give a reference. Now see, Newton's third law of pair of forces. Two forces equal in magnitude, opposite in direction. Acting on two different bodies and acting in opposite direction. So this was the average force of the floor on the ball. Floor on the ball, this one will be the force N, upward, normal reaction. Whereas here the force of the ball on the floor, that will be downward. So this answer is, so according to Newton's third law, both forces will be equal. So if I'm saying F1, that will be equal to F2, but in opposite direction. So that's what is there. So that's why we are writing what? We are writing that F1 is equal to F2. Please, my dear friends, if anybody having any question here, any problem, feel free. You people can ask me. Muhammad Ashraf, Muhammad Naji,
No questions.
Understood.
Understood.
Okay, then let's move forward. Next is define for a wire stress. And last time we did this question. We did some questions on general physics, mechanics, but we couldn't solve any question on this stress and strain, something like that. So stress is defined. So stress is force per unit area, and force is basically a normal force, and better to write it that force is normal to the plane of the area, or we can write only area. Force is normal to the plane of the area. So I wrote only normal to the area. Strain, it is the change in length over original length, या change in length per unit length. So strain is change in length per unit original length. Per unit original length. Even my dear friends, you can, to understand this well, so I can give you that stress is equal to force over area and strain is equal to X over L, or change delta L over L, or it can also be written delta L over L in any way. So that is correct. Now, a school experiment is performed on a metal wire to determine the Young's modulus of a metal, E. Young's modulus E. A force is applied to one end of the wire, which is fixed at the other end. So the variation of the force F with extension X of the wire is shown in figure 4.1. Now, the maximum force applied to the wire is F1. This is F1. The gradient of the graph is the line in figure. The gradient of the graph line in the figure is G. That is F over X. The wire has initial length L and cross-sectional area A. Determine expression in terms of A, G, and L for the Young modulus E. Young modulus E of the wire. Okay. Gradient of this graph, that is rise over run. So it means change in force over change in extension. That is gradient. Okay. Even this can be said F over X. Why? Because graph is started from origin. So let's suppose this F1 minus 0, F, X minus 0, X. So that's why you can write F over X also. Now, we have to write the Young's modulus of the metal in terms of A, G, and L. A. Okay, first of all, Young modulus E, that is equal to stress over strain. I told you many times that we can write it directly F into L over AX. Even last class also I told you how to do it. I think last MCQ we did the same fashion. So FL over AX. Okay. Okay. Little bit modification is how many marks? 2. Okay, then fine. Now see my dear friends, I can also write it F over X times L over A. So, my dear friends, yes, G is not there. In terms of G, A is there, L is there, G was not there. So it's very simple. Now see, A is equal to G L over A. So that's what they want. They want expression for E. Yes, my dear friend, expression for E, Young modulus in terms of A, L, and G. Yeah, is that okay? So we can write it E is equal to G L over A. That's what they want. Yes, my dear friends, comment on this. Is that okay? Or I'm missing something? Muhammad
Understood.
Ashraf, is that fine?
Yes.
Actually, by the way, these sort of points, these sort of questions are my weak point. I'm always confused by them. Those are A, G, L, so G is there. Yeah, it's okay. And see, this equation, again, let me tell you, maybe you will say, sir, you have done it so directly, stress over strain. So, my dear friend, stress is force per unit area. Many times we discussed it. Now that is change in length over original length. So E can be equal to F over A divided by X over L. So E is equal to F over A times L over X. And this implies that E is equal to FL over AX. That's what I used directly here. So Please memorize it because this is easy way. If we are doing it this way, then it becomes easy. Sometime we need to calculate the radius of the wire. Then we can make area as the subject of equation and then pi r square and making r as the subject of equation. So this is basically very easy. Sometimes we need to calculate the change in length. So x can be the subject. Final length, then x can be the subject of equation, then L2 minus L1. So L2 will be equal to this. So this way it becomes so easy to deal many equations. Okay, now a student repeats the experiment in B1 using a new wire. Okay, that is twice the diameter. Diameter is 2D. First wire, the initial length of the wire and the metal of the wire are unchanged. So if the length is, it means the length is same, and metal, it means, Young's modulus is the property of the material. If the material is same, so Young modulus is also same. So what to do? Okay, on figure 4.1, draw the graph line representing the new wire of the force increased from F is equal to 0 to F equal to F1. F is equal to 0 to F is equal to F1. So, okay, wait. See, this one, my dear friends, can be answered with the help of this. See, Young's modulus, it is depending on length and area. So now area will be changed. So if the diameter is doubled, yes, correct. If the diameter is doubled, so area will be increased by 4 times. So if the diameter is doubled, area will be increased by 4 times. Why? My dear friends, we know area is basically equal to pi r square. So this implies that in terms of diameter, area will be equal to pi d square over 4. So if the diameter will be doubled, area will be increased by 4 times. So this implies that for 2 times t, area will be increased by 4 times. Okay. Now what will happen to Young's modulus? Area is increased by 4 times, my dear friends. So what will happen to Young's modulus? Let's go back to the diagram here. Okay, I'm going to rub this. I will use this diagram for some calculations. Now, my dear friends, they said draw this diagram from F is equal to 0 to F is equal to F1. So F will be staying same. Okay. Here we did something, E is equal to GL over A. So, see, my dear friends, E is equal to GL over A. We need to draw it. So gradient. Wait a minute. Let's make gradient as the subject of equation. It will become EA over L. Okay. So, yes, got it. So gradient will be proportional to area, as E is same and L is same. My dear friends, just we discussed here, and it is mentioned here that initial length of the wire is same and the metal is same, so E and L same. So this way, so area is increased by 4 times. So this gradient should also be increased by 4 times. So it means gradient should be increased by 4 times as area is increased by 4 times. Now, what is the gradient right now? 10, 20, 20 over. I'm just counting the small boxes. There is no other thing. 10. This is 10, 11, 12, 13, 14, 15, 16. So 20 over 16. Gradient is increased by 4 times. And this will stay same. The bit tricky, my dear sons. Please try to get it. This is staying same. Now, if the gradient is increased by 4 times, so area should be decreased by 4 times. So this should be divided by 4. It means now graph should be 20 over 4. So see 1, 2, 3, 4. So this graph should be like this, mean straight line, but like this straight line up to here. You can draw it in a better way. So my dear friends, like this, okay, this way. Why so? Again, please, bit tricky, and only 2 marks, but bit tricky. So here, what to do, dear friends, what to do? We calculated first how much area will be increased. Now, when we checked that diameter is doubled, so area will be increased by 4 times. Now they said plot a graph on figure 4.1. Why did I come back here? See, it was figure 4.1. On figure 4.1, F is equal to 0 to F is equal to F1. So force will not be changed. Force will stay same. This is already up to F1. See, this point is already up to F1. Now, length is same length for the new wire and material is also same. So length is same. If material is same, so Young's modulus is the property of material. So it means Young modulus is also same. So making gradient as the subject of equation, so it will become EA over L. From this part you can say A, B1. E is constant, L is constant, it means gradient is directly proportional to area. Now area is increased by 4 times, so gradient should also be increased by 4 times. Gradient is force over extension. Force is still F1. Till F1 we have to go, means force will stay same. So how we can increase the gradient by 4 times? It means by decreasing the extension by 4 times. So before it is 20 over 16. When I'm counting the boxes, along y-axis they are 20, along x-axis till the line of this, till this point, that is 16. So to make the gradient 4 times more, I will reduce this 16 to 4 times 4. So 20 over 16 and 20 over 4. So you can check even 20 over 16. If I'm making, my dear friends, now 20 over 16, just a minute. 20 divided by 16, answer is 1.25. Similarly, now 20 over 4, answer is 5. So see, 1.25 times 4, answer is 5. So exactly, little bit thinking will be needed to solve this question, but be more vigilant. And if you are not understanding, then it will be very difficult in exam. So you can go to the next questions and then come back. So here also, why gradient? Because we have to plot a graph, and now area is increased by 4 times. So gradient will also be increased by 4 times. So this graph will be above the previously drawn graph. So that gradient is greater because force will be more. So how to calculate it? Gradient we will increase by 4 times. Right now gradient we checked, it is 1.25, and when 1.25 times 4, it will be 5. So now you can calculate the gradient here, it will be exactly 5. Okay, my dear friends, so we need to be bit vigilant here and more careful to solve this question. Okay, let's move forward. Now another student repeats the original experiment in B1 and now increasing the force beyond F1 to a new maximum force F2. Okay, from F1 to F2. The new graph obtained is shown in figure 4.2 on figure 4.2, shade an area that represents the work done on the work done to extend the wire when the force is increased from F1 to F2. That's not a problem because this is force extension graph. So area under the graph is the energy. So work done is equal to energy. So my dear friends, this area you can shade for 1 mark. This is so simple. Because how much work is done to extend the wire. So already it is up to F1. Now it is up to F2. So this area under the graph, that will be the work done on the wire and that will be the energy stored. Anyhow, so now the student explain how the student can check the elastic limit of the wire was not exceeded when the force F2 was applied. Very simple. This one is proportionality limit. This one is the limit of proportionality, LOP in shortcut. And we have to check either the force elastic limit is exceeded or no. Simply remove all the forces. If the object or the wire comes back to its original length, it means elastic limit is not exceeded, otherwise it is exceeded. So what I'm going to write, quickly I will be writing on removing the force, if wire comes back to its original length, then elastic limit is not exceeded. Elastic limit is not exceeded. Otherwise, it will be exceeded. So it was not exceeded. So you just remove the forces. And if the wire comes back to its original length, it means elastic limit is still maintained. It's not exceeded. Okay. So that's very simple. Then the next one is each student in the class performs experiment in B1. The teacher describes the values of the Young modulus calculated by the student as having high accuracy and low precision. So what is meant by low precision? The values calculated by different students are not very close to each other, or there is a high range of the values. Anyway, we can say there is what? There is high range of the values, we can say. So, my dear friends, we can write the values found by the students are not very close. Are not very close. So that's what we can do. Okay. Or you can say have large range, mean they are in a large range. Anyone you can write, that's very simple. And here again, I just want to say it, my dear sons, that this value up to here, this was 20 and this was 16. Now again, if we do this one, this is still 20, but this one up to here is 4, so that you can get the idea when you are revising it. Okay, so please, anybody having any question regarding this question, feel free, quickly you can ask me. Yes, my dear friends, if there is any.
Understood.
Okay.
Understood.
Ahmed, Mahad, Talha.
Understood.
Now,
Yes, sir.
a progressive wave y passes a point P, the variation progressive wave, a wave that transfers energy from one point to the other point, from one place to the other place. The variation with the time t of the displacement x of the wave at P is shown in figure 5.1. So x, but this is in millimeters, be very careful, and time is in seconds. So the wave has a wavelength of 8 centimeters, lambda is given, and we need to convert it into meters. So it will be equal to 8 times 10 raised to power minus 2 meters. Determine the speed. Speed v is equal to f lambda is the formula that we are going to use, my dear friends. So V is equal to F lambda. We don't have F, so this V should not be very capital. It should be small for speed. So F we can calculate easily. See the period is how much? 0.4. So F is equal to 1 over T. Here T is equal to 0.4 seconds time required to complete one cycle, one wave. So F is equal to 1 over 0.4. So 1 divided by 0.4, answer is 2.5. So frequency is how much? 2.5 hertz. And then it will be 2.5 times 10, sorry, 8 times 10 raised to the power of minus 2. So as we simplify, we are getting the answer 25. So it should be 4, I think. No, not 4, that is 0.8. Okay. 10 raised to power minus 2 also. So answer comes to be 0.2 meters per second. Very simple. Now, a second wave has a wavelength 8 centimeters. Second wave Z, wavelength is same and amplitude is 2 at point P. Waves Y and Z have the same speed. Same wavelength, same speed. Amplitude for wave Z is 2 and amplitude here is 4, by the way, for this wave X. Wave Y, sorry, amplitude is 4. Okay, amplitude is different. So for the waves at point P, calculate the ratio of intensity of the wave Z to intensity of the wave Y. So my dear friends, that is very simple. No need to worry. Intensity is proportional to square of the amplitude. Many times, sometimes we need to graph and we are using this equation. So ratio of the intensity of y, z to this. So we can do one thing, that intensity of z to intensity of y, that will be equal to over, they should be separate squares, but I'm putting as a whole squares. So very simple, just the values are there. Amplitude of wave z is 2 and for ay that is 4. How do I know? Check here and see, this is in millimeters, this is 4 for y, and here, and don't forget to take the square. So when you will take the square, so answer will be 0.25. Quite simple, by the way, this question for physics of waves. So first of all, wavelength is given and speed we need to find from the graph. Easily we can calculate the period, and if period we have, then it means easily we can calculate the frequency, and then V is equal to F lambda, and we can calculate the answer. Okay, my dear friends. So then this is done, and then intensity is proportional to amplitude square. So Iz over Iy, then just placing the values and getting the answer. Oh, again the waves question. So describe the condition required for the two waves to be able to form a stationary wave. Very common question in exams. So when two progressive waves having the same wavelength, same speed, and same amplitude travel in opposite direction, overlap, so they form what? So I'm writing it in this way, that two progressive waves with same wavelength, same speed, and same amplitude, I'm writing A, travel in opposite direction and overlap or superpose, you can say, even give rise to stationary wave. They give rise to what? So just definition in any way in your words you can write give rise to stationary wave. This is simply a definition. Next one is also so simple. Now see what is there. A stationary wave on a string has a node and has nodes and antinodes. The distance between a node and antinode is adjacent antinode is 6 centimeter. So what is meant by the node? What is this? I'm writing just shortcut point of 0 amplitude mean this point where there is no vibrations. So point of 0 amplitude. I'm sure no problem. Calculate the wavelength of the two waves forming the stationary wave. Wavelength of the two waves forming the stationary wave. So my dear friends, better we should first draw roughly a wave like this. So then for stationary waves, my dear friend, we can this way roughly I have made a wave. So my dear friends, this point will be taken as node. This one will also be node. This one will be node. This one will be node. So now this is antinode. This is also antinode. This is also antinode. Okay. Now what is mentioned? The distance between a node and adjacent antinode. It means the distance from here to here. That is how much? That is 6 centimeter. And we know distance from one node to the antinode, that is basically lambda by 4 equal to 6 centimeters. This implies that lambda is equal to 6 times 4. So that is simply 24 and no need to convert it is in centimeters. My dear son, see in physics of waves, when we talk about stationary waves, so distance from one node to the next node, lambda by 2. Distance from one antinode to the next antinode, lambda by 2. But when it is even half, from node to next antinode, it will be lambda by 4. So that is how much 6 centimeter make lambda as the subject of equation. You will get the answer. Now next is state the phase difference. Now here they said just state the phase difference. No calculation is needed. State the phase difference between the particles at two adjacent nodes of the stationary wave. Like we can take one node here and other one node here. So see, one is up, other one is down. So simply they are anti-parallel. Phase difference, it simply means 180 degrees. No need to waste a lot of time here. So some questions are quite simple. Okay, so this is, they are not in the same direction actually, but whatever this, if this one is downward and this one is what? Upward here. So they are in anti-parallel. So anti-parallel, what is the angle? 180 degree, and degree is already written. No need to write the angle degree. So let's move forward. Define Ohm. So V is equal to IR, R is equal to V over I, because Ohm is equal to volt per ampere. So simply you can write volt per ampere, that is equal to what? Ohm 1 mark. Let's see the next question now. A uniform wire has a resistance this, R is given, length is given, from a metal of resistivity this nano ohm meter. So this resistivity is given, calculate the cross sectional area. Simply R is equal to rho L over A. So let's make area as the subject of equation. It will become rho L over R. So place the values. So my dear friends, area will be equal to rho 460. It was nano ohm meter times 10 raised to power minus 9 times length, that is 2.5, over resistance, that is 3.2, and when we calculate it, answer comes to be roughly 3.6 times 10 raised to power minus, not 2, minus 7 actually, nano is there. So my dear friends, we can write here 3.6 times 10 raised to the power minus 7 and meter square. Very simple, straightforward, and I was surprised why it is for 3 marks. Now, a cell, this was straightforward question. A cell of electromotive force E and internal resistance R is connected to a variable resistor of resistance R as shown in figure 7.1. The current in the circuit is I, as it is a series circuit, so current is staying same. So what is mentioned, that state in terms of energy, why the potential difference across the variable resistor mean here, that is terminal potential difference also is less than the EMF of the battery. So we will say sum of the energy is lost across the internal resistance of the battery. Okay, so why in terms of energy, why potential difference? So sum of, these are in terms of energy, sum of the energy is lost there is internal resistance, so across where, across internal resistance as heat, this is internal resistance, and here some volts are lost, the lost volts are there. Very simple. Okay, let's move forward. State an expression for E in terms of I, R, and R. Very simple, according to Kirchhoff's second law, EMF of the battery is equal to sum of the potential differences. So that is equal to I capital R plus I small r. You may be thinking, sir, what you have done? See, according to Kirchhoff's second law, sum of EMFs is equal to sum of potential differences. Now, EMF of the battery is written already. That is what? That is E. So what is the potential difference lost here? That will be equal to I small r. What is the potential difference lost here? IR. And this is a series circuit. We also know V is equal to V1 plus V2. V total. So V total is E. So I wrote E. I1, that is, sorry, V1 IR plus I small r. This is the volts lost, or this is the terminal potential difference, which is across the variable resistor, and this is the volts lost, which is across the uh, internal resistance. So E is equal to IR plus IR. So they said, okay, even we can write it. E is equal to I common. So R plus R. So my dear friend, here I can write E is equal to I into R plus R. One mark only. Now, the resistance R of the variable resistor is changed so that it is equal to R. Okay, it means capital R is equal to small r. Now derive an expression in terms of only E, R, and P for the power dissipation in the resistor. Power dissipation in the resistor. So, my dear friends, what can we do here? Let's calculate current, and then in terms of R and R. Okay, anyhow, let's start, my dear, from the same equation. We need to calculate power dissipation. So P is equal to, we know that is I square R. Okay. And in this case, P will be equal to I square small r, because we need to write it in terms of R and these are equal. But first of all, we need to calculate I, and that we can get from here. No problem. So, my dear friends, E is equal to I times R plus R. Then making I as the subject of equation, it will become E over R plus R, and I can write I is equal to E over small r plus small r. This implies that I is equal to E over 2R, my dear friends. That's what job is done now. Simple is that now, we can put it. Now, they said power dissipated in terms of these values E, R, and P. No worries at all. P is equal to, we know, I square R. Now place the value, and this implies that P is equal to I square small r, but they are both equal. Now, my dear, this implies that P is equal to E over 2r and whole square times r. So P will be equal to E square over 4r square times r. Now this r will be cancelling this square. So my dear friends, what is the answer? P is equal to E square over 4r. So it means E square over 4r. That's what we will do. But this time in this paper, two types of convergence are there. One was in Young's modulus, another one is here now. So, but it's not very difficult. See, this is linked with this, so easily we can reach it and we can get it. Now the last question, and that is, my dear friends, on state a similarity and a difference between down quark and down anti-quark. You know, antiparticle. Similarity, same mass. Like electron, its antimatter is antiparticle is positron. So they have same mass. So this is the similarity. And what about the difference? Opposite charge. Opposite charge, very simple, 2 marks. Okay, then next. For a nucleus of aluminium 13Al12, state the number of protons and number of neutrons. Very simple. Number of protons are 13 and number of neutrons, nucleon minus number of proton, that is equal to 12. So simply that is equal to 12. Very simple. Show that the charge is this much on this aluminium. So how we can get the charge? How many neutrons has no charge? How many protons are there? 13. So you know charge will be equal to, that is also very simple. Charge will be equal to, my dear sons, see how many protons are there? 13. And charge on one proton or one electron, that is 1.6 times 10 raised to the power of minus 19. So when we simplify this, mean we multiply this, we are getting the answer equal to 2.08 times 10 raised to the power of minus 18. And we can round it off to 2.1 times 10 raised to power minus 18 coulomb. Okay, dear sons. So this is very simple. They said show that the charge, total charge, means proton have charge, neutrons have no charge. So simply multiply the number of protons with the charge on one proton. Then the nucleus can be moved along a straight line from point A to B in a uniform electric field. My dear friends, sorry, this is 2020. So electric field is in A2 physics now, no more in AS. So we will skip this question. Okay, my dear friends. So in this way, today, first attempt, we try to calculate the whole paper, and alhamdulillah it is done. I was explaining more, but I'm sure that you people can do this paper exactly in 1 hour and 15 minutes, because time allowed is 1 hour and 15 minutes, and you people are in a position to do it, inshallah. In case of any doubt, you can ask me. I will share the link of this recording, inshallah, with you people after the lesson, but most probably after the iftar. And paper I'm sharing with you right now, inshallah, as I will be stopping the lesson. Stay blessed, all of you. And in case of any question, any query, feel free. Don't just be looking for these questions. You can sort out any paper, any question you are having, feeling difficulty, send to me. I will solve and share with you, or I will choose the next time the same paper so that we can discuss. Stay blessed, all of you, and take care.
Assalamu alaikum.